Hello everyone. So in the last video we have seen a clear look at the whole process, okay, of a task that actually does takes an analog input and gives the respective analog output in an LED. Okay, excuse me guys. So the LED is going to work according to our analog input. Okay, so depending on the rotation amount or how much you rotate your variable resistor, how much you rotate it, to that amount the brightness will increase. Okay, if you rotate the other side, I mean decreasing side, how much you rotate in the decreasing side, to that amount the brightness will decrease. Okay, so this resistor or this variable resistor will work like a rotating analog button, okay, like a radio volume button. So here instead of volume we will have the brightness of the LED. Okay, so the code I explained yesterday. So we have two integer variables. Yes, so one is reading the analog value. There were three steps I explained you in the last video. So one is we are taking the analog input value and assigning it to a variable. Then we cannot transfer the value directly to the analog output because the range of the analog input and analog output are different. So we have to do a mapping before transferring the value to the analog output. So we have the map function, and yes, we map it, and the resulting value will be stored in the y value. So y value is the new value that is a mapped new value that is ready to be given into the analog output. Okay, so x is mapped into the new range, and the mapped value is y, and the y value is given as the analog output. Very simple. Okay, so now respective to this input we will get the perfect output. Okay, so this pin mode input and output scenarios are needed because pin mode A0 input is for the analog input. We are connecting our variable resistor to A0, and yes, pin mode 7 is the output because the LED is connected to 7. So you know those things, right? So it's very simple. Only thing is you have studied this separately, you have studied this separately, you have studied this also separately, but now you have to connect them together because there is a value range difference. So you have to connect whatever you have learned together. You have to combine and come up with the solution as always. Okay, so this is cool. So we are good to go with this. So I will simply verify it. So what you can do is you can make the connections excuse me guys, you can make the connection. You can connect an LED to the with the resistor to the pin number 7, excuse me guys, and then you can connect your variable resistor to A0, and obviously you can upload your code. So if you upload the code, then what do you have to do? You have to take a screwdriver, put it inside this cross, and rotate this cross in both sides, and watch what happens to the LED. Okay, so you will see the brightness changing. Okay, you are manually in a controlled manner dimming the LED and increasing the brightness of the LED. Okay, dimming and increasing the brightness. Okay, so brightness controlling, it's a brightness controller actually. Okay, fine. So for our sake, okay, for our own sake, we will try it in the simulation environment, but I am quite sure this will not work perfectly as expected in the simulation environment due to two things. One is this LED fading was not working already as well properly. Okay, either it was not working properly or it is not showing properly, we don't know, because this is a simulation environment. Okay, so in this scenario, Tinkercad is actually very good, but in this scenario it is not working properly or it is not showing properly, we don't know. And also this resistor rotation, variable resistor rotation, you know, this is a variable resistor in the simulation environment because we have studied it earlier as well. Okay, so in this variable resistor rotation, when I click and rotate, and once I release the click, okay, let's say I'm rotating it to some extent, and once I rotate it, and then only if I remove my mouse click, then only the value will be the change will be implemented, the change will be affected, the new value will be showing in the Arduino, right? So but in the real variable resistor, you don't have to do such things. Like if while you are rotating the variable, the value will be changing, input value. Okay, the very moment you are rotating, the input value will be changing. But in the simulation environment, the problem is while you are rotating, it will not change. Only once you have completed the rotation and release the mouse, then only the value will be changing. So there are two problems. don't worry, we will just try with the simulation environment, and of course in the real environment it will work perfect for you. Okay, so you can do it by yourself. You only need to have an Arduino and a resistor and LED and this variable resistor thing, this potentiometer. Then you are good to test and it will work. There's no question on that. Okay, you can let me know in the comments whether it is working or not. For our sake, we will go for this. So just to verify that we are getting the different what do you call, I'm sorry guys, analog values. I will quickly maybe at the end of this line, okay, after this output is given, I will have to serial println just to print the values. Okay, so to see what happens. Okay, so let's have x, let's print x, and then we will have a y. Okay, so both values will be printed as a couple. Okay, so to separate both of them, so let's have a separation line as well. Okay, so what I do is, I'm not explaining line by line, you just can see the output and understand what I am trying to actually doing here in this video. So I'll have something like this just for separation purpose. Okay, so I will know after this line whatever the value is coming is always x, then again a y, then again after this line will come. Okay, so I will take two couples, couple of values after this line. So I will know first one is x and the next one is y. Okay, don't worry, if you don't understand, just rewatch it. It's a very simple thing. Okay, I'm not going to explain it. I'm printing x and y, and to make some separation between each and every printing of x and y, I'm having a line. That's all I'm doing. Okay, that's okay. So then after this, the next iteration again x and y will be printed. So every couple of printing, before and after, I will have a line, or let's say after that I will have line. Okay, we are good. So what should I do now? Okay, I will verify again. Verification should be fine. Okay, compiling is fine. I will copy the code, I will open my window, I will go, yeah, it says some connection lost. I will try to reconnect my internet. We'll see what happens. Give me a minute guys. Okay, it's reconnecting. Something wrong with my internet. Okay, now it looks like all good. Okay, now I will open the code, I will paste it, and I'm going to run it. Okay, so let's see what happens. I will start the simulation. What is this thing? I will open my serial monitor and see what happens. I made a mistake. What is that guys? I forgot to tell it here, right? When you are doing a serial println, serial.begin I have to tell. Okay, that's my mistake. Serial.begin 9600. Okay, so now I'm good. What is this? So now the code is fine. You understand what I'm telling, okay guys? So this should be happening, right? I forgot to have it. That's my mistake. Okay, sorry guys. So this is the final code. You can try. So let's go here. Sorry. What happens? I will stop the simulation first. And let's say Control+V. So I'm not going to show it here. Catch me up in the next video. There we will see what happens in the simulation, guys. Okay, just follow me in the next video.